Today we're going to do a practice AP question, and it has to do with bond polarity. So this is the question that you might get here. Which bond is more electronegative? So this actually activates a couple of different things that we've talked about. You need to know what electronegativity is, and you need to know that there is a dedicated periodic table with electronegativity values for each of the elements. And then you need to know how to apply that knowledge in order to figure out which bond is more electronegative. Okay? So the first thing I need to do is I go to my periodic table, and I know that fluorine in a covalent bond like we have them here is 398. Okay? Nitrogen is 3.04 and hydrogen is 2.20. So those are the values of electronegativities. And at this point, it's pretty obvious which one is going to be the most electronegative. But I'll show you how to figure that out. All you got to do is take the difference. Now this one is easy. 398 minus 398, 0. So that is non-polar covalent. These electrons are shared perfectly. Okay? Now I'll tell you the other thing that we should do is we probably should put our other valence electrons in there. I'm going to go ahead and make those pretty and correct. So when I did this, what I did is I put the unshared pairs in there, and you should always put the unshared pairs in. Now nitrogen, I put single here because nitrogen wants to make 3 bonds. So really, this would be something more like this. Sometimes AP questions get a little sloppy, so we can fix them. So that would be that. But we can just take any one of those bonds. They're all going to have the same polarity. So 3.98 minus 3.04. That one is 4, 9.94. That's polar covalent, and so I just have to figure out what my next one is. So 3.98 minus 2.20, 8, 7. Oh, we have a winner. So the difference between the hydrogen and the fluorine is 1.78. That got up to like over a 2. That would be an ionic bond. So this is not shared equally at all. And that's because the hydrogen is really tiny. It only has 1 proton. It can't pull the electron near it hardly at all. And fluorine has like, 9 electrons in it. Or it has 9 protons, has 9 protons in it. And they're all pulling toward the fluorine electron cloud, so that hydrogen electron really doesn't have a chance. It's like just sort of sucked in here, and that's why this number is so large.